Hello again. So now we're going to do another example where I'm going to illustrate how the normal arithmetic calculations that we learn in elementary school can be extended into the formation of algebraic expressions. Okay, let's do that here. A taxi cab company charges a flat fee of $3 for pickup and an additional 25 cents per mile. Okay, so if we were thinking about this problem, and we want to think about one of the things we might want to think about is how much a taxi cab ride is going to cost us. And so in our table, we're going to write miles here because, of course, here we know that it's 25 cents per mile additional above the flat fee. And here, what we're going to do is we're going to count the cost, okay? Because, of course, here it's clear that what's interesting, what's at issue here is a cost. We're going to be charged a flat fee of $3 in case if the taxi picks us up in the first place. And then for each mile we drive, they're going to charge us 25 cents. Okay? So the first part of this table is straightforward. It's going to be 0 miles. Well, if we went 0 miles, but we got picked up, then it's $3. Okay? Okay. So that's the first one. That one's the easy part. What if we go 1 mile? Okay, if we go 1 mile, I know that what I'm going to end up doing is I'm going to say, okay, additional 25 cents per mile, so 0.25 times 1 plus the $3 flat fee. Now I know anything times 1 is just that thing, so this will simplify to 0.25 times, so to 0.25 rather. Okay. Plus 3. And so we know that if we do 0.25 plus 3, well, we can line that up like this. Let me do that very explicitly. It'll be 3.00, 0.25. I add them. 0 plus 5 is 5. 0 plus 2 is 2. I bring down my decimal place. 3 plus 0 is 3. I can see that if I drive 1 mile, I go 3.25. And notice the structure of the expression I calculated to get this. It was this expression, okay? Now, what about for, let's say, 2 miles? As you might imagine, well, so I'm going to drive 2 miles. So it's going to be 25 cents for the first mile, plus 25 cents for the second mile. So it's going to be 0.25 plus 0.25, and then plus the $3 flat fee. And so, again, we remember repeated addition, right? If we have 0.25 plus 0.25, we're adding the 0.25 twice with itself. That means that it's 2 times 0.25. So in other words, this line here will be 0.25 times 2 plus 3. Now, what is 0.25 times 2? Well, it'll be 0.25 times 2 like this. Okay? The 2 times 5 is 10, so I bring down the 0, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 0 is 0. And then I know that there's, out of the total number of factors being multiplied, there are 2 total decimal places. So from here, I'm going to move once, twice, to get a value of 0.5. So this expression then simplifies to 0.50 plus 3. How do we add this? Well, it'll be 3.00 plus 0.50. And when 0 plus 0 is 0, 0 plus 5 is 5. We bring down the decimal place. 3 plus 0 is 3. And so we know that here it'll be 3.5 as the amount I'm spending on the taxi cab for a ride of 2 miles. So now, usually, we don't know how far we're going to go in the taxi cab when we get in. We know roughly that we want to go to a particular location, whatever, but we don't know the exact location, the distance. But I can now state exactly how much I'm going to pay via an algebraic expression. If I travel X miles, I want you to look at this pattern that I did over here. For 1 mile, I had to do 0.25 times 1 plus 3. For 2 miles, I had to do 0.25 times 2 plus 3. And so I imagine now that it might not be too hard to accept that the expression for traveling X miles, the expression for the cost that is, will be 0.25 x plus 3. I want you, so let me just make a brief caveat here. Here, since I have the number next to the variable x, that means 0.25 times x. Here, I was using the multiplication symbol x. And unfortunately, this is one of the confusing things that can happen with so many kinds of human discourse, that certain notations can be kind of like overloaded with meanings. In this case, since I'm multiplying two numbers, I use the cross to indicate the multiplication. But here, I'm using the x to represent the variable that is being used to represent the number of miles. Okay? And so now, in general, we can say that for X miles, the cost that I'm going to incur riding this taxi will be 0.25x plus 3. Okay? And what else do I want to say about this? Oh, yes. So, and again, this goes to what I was saying earlier. What we learned in terms of arithmetic in elementary school is perfectly satisfactory when all the problems when all the problem parameters are known. I'm gonna drive 15 miles. How much will my taxi cab cost? Well, I can calculate it like I did for this table, right? But the question becomes, can I express in a precise way a situation where not all the parameters are known? And what I've shown here is that that's what the addition of variables permits. If I can assign a variable to represent the miles, then imitating the arithmetic calculation, I can express in an algebraic expression the exact cost. Thank you.